This video we will see how can we perform conditional fitting using Fitteia. Imagine you want to fit this dataset shown in the graph. We can separate three regions. The first one, which I previously checked, goes up to t is equal to 2910. Seems to be best fitting by a constant. The second region reach over from t is equal to 2910 to t is equal to 5715, and the third one start from the last value onward. These last two regions appear to be well fitted by sinusoidal function whose altitude decays exponentially over time plus a constant around which the oscillation occurs. Naturally, we could separate the data into these three regions and fit these individually, but we can also define a piecewise function and fit these three regions at the same time. Let's go ahead and write this model in our model function. We start to write our function. We replace x with t, which makes more sense. Let's remove the default linear equation that is usually present here, and now we write the model. Inside parameter, we define the first conditions. So we will write our function on this part, and also we need to mention our parameters in above. If t less than 2910, we fit a constant which we call y01. Otherwise, else if t is greater than this value and less than 5715, we fit a function. At this point, let's declare the parameters. So our parameters will be written in the above box on parameters part, and we declare y01, y02, a2, lambda2, omega2, pi2. So our function is okay, and we declare our parameters, remove parameter and mention on there. So after declaring our parameters, else we fit same function, but instead of y2 and a2 etc, we call everything y3, a3 and so on. We just replace the 2s with 3s. Now we press compile and we check our function and everything is okay. So these are all our parameters. Lambda 2, yeah. Lambda 3, yeah. Omega 3 and pi 3. So we will compile. Yeah, parameter initialization and partial fitting. We now have a table with all parameters, which we mention below. As usually, they are initially fixed and set to 1. If we free all parameter at once, the press fit, we see that program cannot properly fit all data except of course, for the first part, which was a constant. We can try another approach, fitting in step. How do we do this? In the data block, we must insert at least the first row. So we write fit if C1 less than 5715 or 1. This means we only fitting data up to this point. The segment is already well fitted, so now we adjust one only this part. The one means we fit every point, but we could not fit every 2 point instead. This can speed up fitting because using few points. Now let's fix the parameter that should not be optimized and press fit. So we will go our parameters and we click and do it in the value of fixed. So now press fit. estimated parameter. At this point, our last option is to estimate sum of parameters. This issue rises because the parameters are too far from their expected values. Omega is simply 2 pi over period. The period can observe in the graph. It is about 500, maybe a bit more, around 600. So we set omega is equal to 2 pi over 600. For lambda, it is roughly that inverse of the time it takes for the amplitude to decrease of about 1 over 3 of its value. For here, the amplitude decrease about 1 over 3, the corresponding to about 1000, not quite 1500, maybe 1000 or 300 or 200. So we set lambda is equal to 1 over 1300 and press the fit. One over 1300, yes, and fit. Now we fit using all point and we see that it worked fine. Combine all data point. Let's see, add the missing point. We set C1 less than 10,000, which, so here we will write C1 less than 10,000, which practically include all data points, which use previously obtained values as estimates for parameters of the third region, which has very similar behavior. We free these parameters and press the fit. Free all the parameter which was fixed. So now press the fit. Now we successfully fit all region. Finally, notice by using these if condition, we can easily fit piecewise function. Moreover, by using fit if and plot if, we can control which part of data we are fitting a given time. These also help avoid using too many points, which might slow down the fit. Lastly, we conditional fit. You can also separate different contribution as we saw in this video and explain the plotter module. However, you cannot do this directly inside the condition. You cannot simple write slash plus inside the condition. Yeah, slash plus. You must separate each condition, one condition for constant part and other is for exponentially decay cosine term. For example, in this case, here we set 0 and here we set only the constant. Now we press compile. Yeah, is constant and is we will set as 0 and we click on compile and slightly adjust the appearance of the curve so they do not overlap with the main fitted curve. We now see the separated conditions in this case. Yeah, is plot. It takes some time. Yeah, every separated conditions are shown in the graph. Practice these fits as we will use them frequently in the upcoming videos. Thank you so much.